In session 3, we're going to be talking about the control statements. We're going to be talking about how the program is fluid, what is the logic that things are going to follow. So we're going to learn what is an if-else statement, what is a switch statement, what is a loop, what is an array, and what are strings. So let's get started. An if-else is basically when we have to make a decision. It's a choice where if something is true, then the contents of that condition happen. Here it's a diagram of how it is represented in UML. In basically any logic situation where you have a true false, you have this condition that it's represented in the A, and then the situations that are represented between the B and C that B happens if A is correct, if A is true, and B and C happens if A is false. Here also I am representing an if-else true thing in pseudo code, which is not particularly any programming language. It's just good enough for somebody to read it and to understand what are the values that we're gonna have, or what we can actually understand what we are trying to accomplish without really having to write the perfect syntax of a program. So I'm representing here an if-else in two ways: pseudocode and as a diagram. All right, so how do we then represent an if-else in Java? So we have the keyword if, and the condition is something that must happen in those parentheses. In this case, we have two keywords that have the if and the else. In the condition, you can see if a particular laptop is in stock, then we print that it's available. Otherwise, we say that it's unavailable. But not everything is just binary. You either go this way or this way. It's not necessarily like that. Sometimes the choices that we have become more a cascade. If something happens, then do this. If not, but if something else happens, then do this. And if not, and something else happens, do this. And if not the else, which is a catch-all, then do this. So then things become a little bit more complicated because, for example, car rental exercise, we had that if somebody was less than 18, but if somebody was greater than 18 but less than 21, they had a different in less than 18 you couldn't rent. In between 18 and 21 you had to pay a lot, and between 21 and greater than but 25, then you would have to pay just a little bit less, and anyone above, then you would have to pay just basically your 25 plus. You would only pay a certain amount. So this is how we nest them. And we use the if, the condition goes in the parentheses, then the statement that you do with that if is true in between the two curly brackets. And then if you have another condition, you have else if, and the condition again in between parentheses, the condition that would be executed between the curly brackets, and then the catch-all, the condition that would happen would be in between the curly brackets. So right now I'm just generating a random number where every time I run it, it's going to give me a number, positive or negative, between 0 and 10. The reason for this is that we're using a modulo 10, so it's grabbing whatever random number and try to convert it between 0 and 10. So if we want to, actually let's put it between 0 and 6, because that would be the roll of a dice, right? So when we roll a die, then we would get 0 and 6. So let's just make that. And also we want to do math.abs. We're going to use the absolute value of that int, so that way we always get a positive number. So right now, this is the equivalent of us rolling a die, where we are getting 5, 3, 2, etc. So let's assign this value that we created here and put it into a variable. So our int roll is the number that we've been rolling on the die. There are certain situations where we are presented with the possibility of using a switch clause. And the switch situation is a little bit more, it's slightly different, even though that it might look in the surface that they're both the same as an if. They are slightly different. And so how are they different? Well, first of all, the switch statement has this mechanism of cascading through values, where first of all, there's a couple differences. Difference number one is that in an if we had a range of values, say like from 0 to 100, right? We can evaluate if some values, say like from 0 to 8, all these values we could say, and then we can evaluate this guy. So what it means is that we can, in an if, we can check all the values, the infinite amount of values that are between each numbers. We can evaluate those with an if, even if it's like 3.3, 3.4. So it doesn't matter how many, like, it's kind of like, I don't want to say analog because it would be using the wrong thing, but when you have a range to play with, an if is recommended. But when you have a set of specific values that you're trying to get or trying to evaluate, a very specific and limited amount of values, a switch might be a better alternative. Actually, the example that I use, this is the example that I typically use is a gym membership, where you might have this web page that may have like basic, plus, and premium. Any subscription service could actually handle it like that, where you have a finite set of categories. We have 1, 2, and 3 of the values that we can switch with, which is the basic, plus, and premium. And where the basic gives you, I don't know, let's say in the basic gym membership, and access to the pool and the locker rooms, right? That's your basic gym membership. In the plus is everything of basic, basic plus, let's assume spa access on weekends. And then you have the premium, which would have everything in plus unlimited classes. Yeah, actually that would be another one. Rather than access on weekend, it would be better to have, I don't know, 5 classes a month. Unlimited classes and your own parking spot. Okay. So, assuming that we have in our case, in our categories, first of all, it is giving us a limited amount of options where we are also cascading through the values. So a switch inside of the parentheses is just what you need to say. It's what's the value that it's going to be switching from. And in this case, it's going to be the membership. So we're going to put like switch membership. And then inside of that, you could say what are the cases. So in the case of basic, you would have, I don't know, gym, and let's put as if it was a function, pool, and locker. So we're basically just describing the extra features. Then case plus, we would say that it's got the spa and then the 5 classes. Also on this guy, rather than calling it class basic, we would call it default. If we didn't put a break keyword, which I'm going to introduce in a second, but it would evaluate, in the case of a premium, it would go and evaluate this one, and then go and evaluate this one, and then go and evaluate this one. So that's a way of doing it in a quite elegant way, where we're not really repeating things. We're just going through those cascading of membership. So if we start with plus, it would not go through the premium one because it didn't start here. But then from that point on, because there's no break, it would continue all the way down through the entire switch options. There are situations where you might want, say, the plus to continue but not go all the way to the default. That is where you use a keyword called break in the switch, which that means stop doing this block and get out of here. So if we added a break on all of these categories, when we did the premium, you would only get the ultimate classes and the unlimited classes and the parking. It wouldn't go and go down to the further levels, because the break is just saying, okay, now that you came here, now get out. So then a switch, because it's a limited amount of values that it can, or a finite number of values that it can process, it supports only a few data types. It supports any number, any char, and a string. In C++ and other languages, C++, a string is not admitted, but in Java they decided that you could, because you can only write so many strings, I would say. So if we go back to this thing, that's basically how it is. So again, the break is what kicks you out of the switch in once a condition is met. If not, it continues going to the next one and then to the next one until it goes into the default or finds a break. Then now let's go into the loops. A loop is basically something where the computer is going to be doing it over and over and over and over and over and over again until a condition is met that will stop it. So the first one that we're seeing here, it is a traditional while, and that's a very common one. What that means, where we enter a condition, if the condition is met, then we keep doing into the condition. So it would be repeating until this guy here, and let me switch colors, until this guy here is says that it's false. So then it would go into the next step. In the case of a pseudocode, this is how we write a while. You can see that there's a do and an end while. In the case of a diagram, this is where it's at. This is a decision, and if it is true, then it goes into this guy and then goes back into the loop, and until it is false, then it continues somewhere else. So this is how we write a while in Java. So in this case, I'm putting a while true to make it continue forever. But just notice that there's that break keyword again. The break keyword essentially means let's just get out of this context. In this case, we are going to be counting in this loop. Let's actually put it in IntelliJ. Let me copy this and paste it in IntelliJ. So this thing is going to count to 10. We're going to count to 10. At the end of, until the end of this thing. Well, there was an 11 because it finished and it said once it's greater than 10. But if we put it greater or equal, then it will stay until 10. So basically it repeated this. And if you want to see it with the debugger, let's just debug it. And now we're gonna continue. It keeps going 3, 4, 5, 6 until it is greater or equal than 10, which is in this case it is at 10. And then when it gets to that, then it hits the brakes and leaves the function and then just prints the last number that we were evaluating. Do while it's very similar to while. You can see that the structure is very similar, but you have the while, the condition at the bottom rather than at the top. There are situations where you need to, at the very least, do the task once and then evaluate if you are done. Driving, that are we there yet? Are we there yet from kids? It is a perfect example of a do while. For example, if you guys wanted to say sort a list, and in that list you at the very least need to go through each one of the elements just to make sure that the list is ordered the way that it is. Basically a do while would be something like this. Let's assume that this is Boolean keep sorting. So we're gonna assume that we're gonna continue doing the job until we don't need to do it anymore. And do while keep sorting. So basically in this guy we're gonna check if array is ordered if array is ordered, then we turn keep sorting off or equals false. And then we can just try to sort the algorithm.